Hey everybody, it's Mr. Sheeline here. This is going to be the video covering the Unit 6.2 notes. We're finally getting into stoichiometry. Okay, just so we are aware of what this packet all includes. So if you take a peek here, we've got 1, 2, 3 problems here. Excuse the bell. Also have 4 and 5 whole practice problems. So hopefully we kind of get an idea here that you know, we're finally to a point to where we are messing with the real deal and we have to be prepared. So we've got 5 different examples lined up for you guys to look at in order to solve for these. Now, what else is included? So there is also, I've got a rough list of steps that you can take to help you learn how to convert these things properly. And this will make more sense as we go along, but I kind of run through this example problem here. There's some notes as to why I'm looking at certain things, why am I using one thing over another, what's all happening. So this right here is just a reference page that helps you just to maybe get a different perspective, a better perspective maybe, on what exactly we're doing. Okay, so it's just like it says up here, extra help steps with notes. And then finally, there's also, we're going to be filling out this graphic organizer. So this graphic organizer is going to help us understand, and this is a tool right here that I want you to be using and to be referring to while we're working on Stoic throughout this unit, because this is going to be invaluable. What we're going to do here, you'll see in a bit, is it's basically we're going to lay out how it is, the steps you take in order to go from one kind of substance to another kind of substance. Okay, so let's get straight to the notes. So, okay, we're taking a look here at stoichiometry. So what is this funny sounding word called stoichiometry? So stoichiometry is using the mathematical relationships present in a balanced chemical equation to determine quantities of reactants and products. That's a fancy way to say that we're going to start with, let's say, the mass of a particular element or compound, and we're going to convert to, we'll say, particles of a different compound or element. Okay? And what we're going to be using here is we're going to be using molar ratios, the things that we learned just in the last section. We're going to be using molar ratios, and we're still going to be using Avogadro's number and also molar mass in order to convert moles between substances. Now, how are we doing this? Well, we're doing this pretty much just like we would do, or we are doing just molar conversions for the most part. The only difference is instead of converting from moles to mass or mass to particles of the same content, the same compounds, the same elements, this time we're going to be converting from one substance to another. So not too different from when we did the molar ratios. Now, before we start looking at these problems, because that's pretty much it as far as me talking about this, before we get into talking about solving these problems, we're going to first fill out this graphic organizer. Okay. Here, I'm going to zoom out just a little bit. Oh, that doesn't really help. Okay, mind your ears. Move this just a little higher. Okay. So we're going to fill out this graphic organizer. So what the point of this graphic organizer, again, is designed to do is to help you organize your thoughts as to, you know, determining, okay, where am I starting, where am I ending, how do I go from one to the other, okay? So we're going to fill it out like this. So, okay, over on this side, we're going to have the mass of A. We're going to have mass of substance A, and we measure that in grams. Now, we're going to follow the arrows. So the arrows tell us how we're getting from one to another in Stoic. So we're going to have a difference between mass of, say, substance A. We're going to have substance B as the other one. So if we start with mass of A, we have to convert from mass of A to moles of A. Measure those in moles. And then once we have our moles of A, well, then we can use the molar ratio in order to convert moles, or 2 moles of B. Okay. Now sometimes that's going to be enough that, in some problems, we just got to go from mass of A to moles of B. Okay, but there's going to be also problems where we're going to start with mass of A and we have to go to mass of B. Okay. Measure that in grams. And so if you had to start with, say, the mass of A here, in order to get to mass of B, first we have to follow the arrow down here to, moles of A, okay? After I convert from moles of A, I then convert to moles of B, okay? And then from moles of B, I convert to mass of B. Okie doke. But that's, again, just if I'm going from mass of A to mass of B. Now, what if I have, let's say, particles of A? So particles of A. Well, remember, particles we measure with atoms, formula units, and then also molecules. So if we started with particles of A, we would have to convert from particles of A to moles of A, and then from moles of A we can then convert to moles of B, and then depending on the question, either we will convert that into mass of B, or we'll go down here and we'll convert to particles of B. Okay, which again is still atoms, formula units, molecules. Now, this is bare bones, just a way to just organize your thoughts on how to go from any one of these, like something of A to something of B. Now, the arrows, we can fill those in like what we would use in order to go from here to here. So from mass to moles, well, that's just going to be, this is a simple molar conversion. Okay, so molar conversion here. So that's, however many mole or however many grams are in a particular number, or in 1 mole of substance A. In order to go from particles of A to moles of A, well, that's Avogadro's number. In any one substance, there is 6.02, or any 1 mole of any substance, there's always 6.02 times 10 to the 23rd particles. Okay. In order to go from moles of A to moles of B, well, that's just the molar ratio. Go from moles of B to mass of B, that's just molar conversion. Okay. But if we didn't want to go to mass of B, we want to go to particles of B, that's still just Avogadro's number. Okay. So what we just laid out here is basically just what the conversion factors are. So if I got to go from mass of A to moles of A, well, I'm just going to use a conversion factor. That's the molar conversion, the molar mass. I should really put molar mass. The molar mass. Parentheses, molar mass. From here to here, yeah, just molar conversion of mass of A to moles of A. I use molar mass in order to convert that. Well, if I want to go from moles of A to moles of B, I use molar ratio. And again, that's the coefficients found inside the balanced equation. Moles of B to mass of B, well, that's just molar conversion, the molar mass. And it's just Avogadro's number if we're, wanting to go from particles of A to moles of A, and then moles of B to particles of B. Okay. So it's pretty busy, decently speaking, but something that is manageable, especially now that we have this nice, neat little graphic organizer. We can use this in order to solve a whole bunch of problems like so. So let's take a look here at example number 1. Okay. So in example number 1 here, determine the moles of lithium hydroxide produced when 0.38 grams of lithium nitride reacts with water according to the following equation. So whole lot of words, spooky, spooky, spooky. Let's just slow things down and let's try to break down these problems. So determine the moles of lithium hydroxide, so something to do with moles of lithium hydroxide, which is going to be this guy right here, produced when 0.38 grams of lithium nitride reacts with water. Okay, so they talk about 3 things here, but we really only need to worry about 2. So it's specifically asking us like the number of moles of lithium hydroxide that'll be produced. But which one of these 2 do we really have to worry about? Do we have to worry about water? Do we have to worry about lithium nitride? So here's a really great key, is that a key idea, is that pretty much you're looking for words like this. determine the moles of. Okay, that's the question. How many moles of this stuff? End of sentence. Okay. And then they'll throw at you the measurement. So 0.38 grams of lithium nitride. And then here we just know that water, we don't care about water. We only care about this stuff because it just says it reacts with water. Well, it's cool that it reacts with water, but we don't care. All we care about is this measurement and this measurement. Okay. So what I just did is that I just broke down how it is that we know what we're going to and from. So in this case, we're going from this to this, and we're not worrying about the water. And we're focusing on this guy and this guy, specifically starting here. So we're starting with 0.38 grams of lithium nitride. And we want to convert grams of lithium nitride to moles of lithium hydroxide. Okay. Now, looking at our, and this is how we're going to use this, how you would use this graphic organizer. So we're starting with the mass of just A. So we're starting here. And we want to end here because it says moles of lithium hydroxide. We want to know how many moles of lithium hydroxide we're going to, that will be produced. So we're starting here, and we want to convert to here. Okay, so we've got to go from here to here, here to here. And that's how we get our answer for number 1. So first I got to go from mass of A, which is going to be lithium nitride, and I need to go to moles of lithium nitride. So then I'm going to do this. Well, I know that the molar mass of lithium nitride is 34.7 grams of lithium nitride. And there's 1 mole in all of that. Okay. So to take a breather real quick. So we're from here to here we would convert from grams or mass lithium nitride to moles of lithium nitride because this would cancel out, this would cancel out, and we'd be left with just moles of lithium nitride. Okay, so now we got to go from moles of lithium nitride to moles of lithium hydroxide. So old units of the moles of lithium nitride go on the bottom, and then the moles of our new substance, lithium hydroxide, are going to go up top. Okay, now this is the molar ratio, so we got to look at what the molar ratio is from lithium nitride to lithium hydroxide. So it looks like lithium nitride has 1 mole to lithium hydroxide having 3 moles. And we would see that this cancels out, that cancels out, and we'd be left with just this number of moles of lithium hydroxide. And as usual, we would multiply across the top, multiply across the bottom, and then divide top from bottom. And then what we should get here, and also keeping sig figs, our answer would be 0.033 moles of lithium hydroxide. And we would have just converted from mass of substance A to moles of substance B. Okay. So let's try example number 2 here. And just to let you know, I think I'm only going to go through these 2 examples. I'll have a separate video just because the way I'm planning everything and I'm doing this video, I'm not going to have enough time to get through all 5. So I'm going to just do 1 and 2, and then I'll have a separate video that's also going to include 3, 4, and 5. Okay. So don't panic. It'll be, all part of the notes, all that good stuff. Okay. So let's real quick, let's look at what we're working with here in example number 2. Okay, so in example number 2, how many formula units of sodium iodide must be used to completely react with 4.37 moles of chlorine gas, given the following equation? Okay, and then we have our complete and balanced chemical equation, and we have to know how many formula units. The question is how many formula units of sodium iodide. So we're going to look here. We're going to see which one's sodium iodide. So that's not, because that's sodium chloride. That's just iodine gas, that's just iodine gas. That's my sodium iodide. And then, as we read on, must be used to completely react with 4.37 moles of chlorine gas. So 4.37 moles of chlorine gas. So chlorine gas, remember Hofbrinkel. Always remember Hofbrinkel. And actually, I'll write this. Remember, because diatoms are going to come back, guys. Remember Hofbrinkel. So remember, these are the diatoms. They're the guys that run around in pairs, because when they run around in pairs, they're in a gaseous form. So that would be this guy right here. That would be iodine here. Now, the thing that you'll see here that we got to be super careful of, or something, or actually not in this problem, but in general, something you got to really watch out for. If you had to convert, let's say, the mass of this guy, remember there's specifically 2 atoms of chlorine there. So in this case, in another problem, if we had to convert to the mass of this or from the mass of this, we'd have to remember that the molar mass of this guy isn't going to be just 35.5. The molar mass of this guy would actually be 76. It'd just be 7. Yeah, it'd be, or no, yeah, or it'd be 71. So because it's 35.5 times 2, so it'd be 71 grams per mole. Because there's 2 atoms of that there. It's not a single element. And I'll have some extra help videos that will be tied along with that, but just something to keep in mind. Here, I don't think we're going to have to do that because we start off with moles of chlorine gas. So we're starting with moles of chlorine gas. And let's try to figure out what we're doing here. Let's try to figure out, using our graphic organizer, where we're going. So again, we're going to start with moles of A, and where we want to end with is we want to end off with particles of B. So our A substance in this case is going to be chlorine gas. Substance B is sodium iodide. And we want to go from moles of A, moles of chlorine gas, to molecules of, formula units of sodium iodide. We want to go here. So in order to do that, we have to go from here to here, and then here to here. Okay? So let's now just first start off. So it looked like we've got to use the molar ratio in order to convert from moles of chlorine gas to moles of sodium iodide. So our old units go on the bottom, and our old compound goes on the bottom, and then our new units and also our new compound go up top. I'm going to use the molar ratio, and it looks like there's one mole of chlorine gas to 2 moles of sodium iodide, so 1 to 2. And then at this point, I would have my units in moles of sodium iodide, but I need to now move to particles of sodium iodide. So this is where we're going to use Avogadro's number. So old units go on the bottom. 1 mole of sodium iodide is equal to 6.02 times 10 to the 23rd particles, in this case, formula units of sodium iodide. Okay, so just to make sure, it looks like this would cancel out because of 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 this, and I'd be left with formula units. I'd be left with formula units of sodium iodide. Okay, so I'd multiply across the top, multiply across the bottom, divide top from bottom, and I'll have my answer here, which in this case is going to be, and again, keeping sig figs, 5.26, and I'm keeping 3 because there's 3 sig figs over here, times 10 to the 24th formula units of sodium iodide. And then I would have my answer. Okay. So, again, it's just we're converting from one particular amount of substance to another. So I've walked you through these. So I'm actually going to really push you guys. Maybe on a separate piece of paper. On a separate piece of paper, I want you to do example 3. I want you to do example 4 and 5 on your own. Okay, I want you to do them on your own. It won't be for a grade. I want you to do them on your own first to really practice, to try to figure out how to solve them. And then after you're done with them, then I want you to come back, and then I want you to watch the check, or I want you to double check your answers with the other video I'll have, which will walk through on how to answer 3, 4, and 5. Okay. And before I leave you guys off to do that, just another reminder about this page. Remember, this is just extra help. So if you think you're good to go, or if you think you're good to go, maybe you don't need this. Maybe you're going to catch on to Stoic like it's no one's business, and you are just going to do super, super well. Okay, and I hope that's the case. But let's say it's not the case for you, whoever you may be. And let's say you need that extra help. So here, again, this is a layout with an example problem. I give some kind of crude steps on pretty much what we just did. You know, identify the two compounds you need to focus on. You can circle them in your chemical equation. Write down the provided values. So it'd be like writing down this guy, you know, and then just walk. It's basically just walking through the steps I just did, but it puts it in word form in case, like, you know, it's a couple days after you've watched this video and you're like, man, how do I go from here to here? What do I need to do? Reference this. Maybe this will help you out, okay? And then finally, just always remember, there's this guy. This guy's going to be great. He's going to be your best friend. Make him be your best friend. He's definitely going to help you along the way. All that good stuff. Oh, and just as a reminder, got to show, and when we practice this, you've got to show all your work. Got to do all of this. Got to have the proper value with the proper number of sig figs, with the proper units, with the proper compound. Okay? All of it. Got to have all of this stuff. Okie doke. Or else in future, you know, when you practice this in the future on actual homework, if you don't have the work, if you don't have the proper value, if you don't have this guy, if you don't have that guy, you're going to lose points. Okay, I need to see it all. So that's the end of the notes here, guys. So if you still have any questions for me, make sure you get a hold of me. If not, I'll just see you guys on the next one.